All right. Hey, everyone. Let's jump into a deep dive into the world of ZK hardware acceleration.
Cool.
I think this is something a lot of you have been asking about. You've been really curious about how to make ZK, faster, how to actually get it to work in the real world.
Yeah, definitely a lot of buzz about it.
For sure. And we've got a great article here that's going to break it all down for us.
It is really interesting what some of the top minds in the space are thinking about this. And even Vitalik Buterin, the co-founder of Ethereum,
Right.
has been saying that hardware acceleration could be the key to unlocking ZK's true potential.
He's like, this is how we make my ZK dreams come true.
Totally.
But before we get into all that, I think we should maybe step back for a second because I get the basic idea of ZK proofs, right? Like proving something's true without revealing the secret sauce.
Right.
But to be honest, some of the technical stuff still kind of trips me up.
Okay, yeah. I mean, ZK proofs can get pretty complex under the hood.
Yeah, for sure. So, how would I explain this to someone who's not a blockchain whiz? What's a ZK proof actually do?
It's like, imagine you want to prove, a secret number that solves the specific equation.
Okay.
But you absolutely cannot reveal the number itself.
Okay.
ZK proofs let you do that in the digital world. It's kind of like this cryptographic magic trick.
I like that. A magic trick.
Yeah, where one person, the prover, convinces another, the verifier, that they've got the right answer without actually spilling the beans about how they got it.
Okay, but blockchain already uses cryptography, right? So what makes ZK proof so special?
Yeah, it's the zero knowledge part that's revolutionary.
Right.
So regular cryptography might hide the contents of a message, but ZK proofs can actually hide the logic behind a computation.
Oh, interesting.
While still guaranteeing it's correct.
Okay.
Yeah, and this just opens up so many possibilities that weren't really feasible before.
All right, so I'm seeing why ZK is a big deal, but I'm kind of hitting a wall with the how, this whole converting problems into a special math format thing.
Right, yeah.
Can you give me, the gist without the hardcore math lesson?
You bet. Basically, think of it like this. ZK proofs. They turn any problem that you want to solve into a kind of mathematical puzzle.
Okay.
And this puzzle uses something called polynomials. Which are equations you might remember from algebra class.
Polynomials. Oh, man. Yeah, those things with the x's and the exponents.
Exactly.
Flashback to high school math class.
Right.
All right, so we've got our problem. We turned it into a polynomial puzzle.
Yeah.
Then what?
Then the prover, the one with the secret knowledge, they solve the puzzle in a way that proves they have the right pieces.
Okay.
But without actually showing those pieces to the verifier, they use these really clever techniques called polynomial commitments.
Okay.
Which are kind of like cryptographic locks that make sure that the prover isn't cheating.
So they're saying, trust me, I solved the puzzle. But they've got this mathematical proof to back it up, but they don't show the pieces.
Right. They keep those puzzle pieces themselves hidden.
Okay.
And because it's all based on math, the verifier can be absolutely sure that that proof is legit.
Got it.
The whole system really comes down to just proving those polynomial equations hold true without revealing the actual input values.
Okay, that actually makes sense. I'm starting to get it.
Awesome.
So we've got these ZK proofs. They can do all sorts of cool things, but there's got to be a catch, right?
Yeah, you're right. There's a catch. And that catch is that these proofs can be super slow to make.
Oh, okay.
That's actually the biggest bottleneck holding ZK back right now from real-world use. Think of it this way. Verifying a ZK proof might only take a second.
Right.
But generating that same proof could take hours, maybe even a whole day.
Whoa, okay, that's a huge difference.
Right.
So what's causing all that slowdown? Is it just the complexity of the math itself?
It's partly that, but there are two main culprits that we can kind of point to. One is MSM, which stands for multiscalar multiplication.
MSM.
And the other one is NTT, or number theoretic transform.
Okay, those sound intense.
Yeah, they're pretty mouthful.
So, break it down for me. What are these things doing that take so long?
So NSM involves a ton of calculations on elliptic curves.
Okay.
Which are these special mathematical structures that are used in cryptography.
Okay.
It's like doing this really complicated dance with points on a curve, and it just takes a ton of computing power.
Oh, wow.
NTT is different. It's all about speeding up calculations with those polynomials that we talked about earlier.
Right.
It's like finding shortcuts in a maze.
Okay.
But even with the shortcuts, it still takes a lot of processing muscle to get it done.
So even with all the clever tricks and optimizations, these MSM and NTT things are still kind of bogging us down.
Yeah, they're big bottlenecks.
So it sounds like we need to call in the reinforcements.
Yes.
We need some hardware acceleration.
Yeah, we need to put those proofs on, like a superhighway.
Yeah, exactly. All right, so we talked about the what of ZK proofs and the why of making them faster.
Right.
Now let's get into the how, the exciting world of hardware that can boost ZK to the next level.
Let's do it.
All right, we'll be back in just a minute.
All right, so we've established that ZK proofs have this awesome potential.
For sure.
But they can be like real slowpokes when it comes to generating those proofs.
Yeah.
It's like having a supercar stuck in rush hour traffic.
Right.
So that's where this whole hardware acceleration thing comes in.
Right.
Like, give me the rundown.
Exactly.
What kind of hardware are we talking about?
Sure.
And how does it actually speed things up?
So just like a supercar needs like a really powerful engine, ZK proofs need this specialized hardware to unleash their full potential.
Okay.
And there are three main contenders in this hardware race.
Okay. A three-way race?
Yep. We've got GPUs,
Okay.
we've got FPGAs, and we've got ASICs.
Okay, so I'm picturing this like epic showdown between these hardware heavyweights.
Right.
So who's in the lead? Well, each contender has their strengths and weaknesses.
Okay.
So it really depends on what you're looking for.
Got it.
Let's start with GPUs.
Okay.
Those are graphics processing units, the things that make our video games look all fancy.
Right.
And they're already widely available, relatively affordable, and pretty easy to program,
Okay.
especially with platforms like NVIDIA's CGA.
Hold on. CUDA. Remind me what that is again.
So CEDA is like a programming language,
Okay.
specifically designed for GPUs.
Gotcha.
You might have come across it if you've ever dabbled in things like machine learning
Okay.
or, even high-end gaming.
Right.
But anyway, this ease of use makes GPUs a great starting point for ZK acceleration.
Got it. So GPUs are kind of like the all-around workhorse.
Exactly.
They're accessible, they're ready to go,
Yeah.
but maybe not the top performer in every single category.
Right. They're great for general-purpose computing,
Yeah.
but they might not be the most efficient for ZK specifically.
Okay.
So let's move on to FPGAs. Those are field programmable gate arrays.
Okay, what are those?
They're kind of like the customizable athletes of the hardware world.
Customizable, so like you can tailor them to be really good at very specific tasks?
Precisely. They're not as readily available as GPUs.
Okay.
And they require a bit more specialized knowledge to work with.
Right.
But they can be tailored to specific ZK algorithms,
Interesting.
which leads to some serious speed and efficiency gains.
Okay, so it's kind of a trade-off.
It's
Easier to
this.
use GPUs versus more specialized FPGAs.
Exactly.
What about ASICs? I thought those were like the kings of performance.
They are. They absolutely are.
When it comes to hardware, right?
Yeah, ASICs are application-specific integrated circuits,
Okay.
and they're like the thoroughbred racehorses of the hardware world.
Ooh, okay.
They're custom built for one very specific purpose,
Right.
which lets them hit incredible speeds.
Gotcha.
But that specialization comes at a cost.
Okay.
They're expensive to develop, and they're not very adaptable.
Right.
If the algorithms change.
So ASICs are like investing in a super specialized piece of equipment.
Yeah.
It's amazing if you know exactly what you need, but risky if things change too quickly.
Right.
So it makes sense that with ZK tech moving so fast, ASICs might be a little bit of a gamble right now.
Yeah, it's definitely a gamble. It's all about finding that balance
Okay.
between performance and flexibility.
Right.
And the best choice depends on the specific needs of the ZK application.
Okay, so this is all super interesting, but who is actually leading the charge in this race? Like, is there a front runner I should be paying attention to?
There are definitely a few companies making waves,
Okay.
but one that stands out is cysic.
CISIC, okay.
They're taking a multi-pronged approach,
Okay.
tackling ZK acceleration with GPUs, FPGAs, and they're even dipping their toes into ASIC development.
Wow, covering all the bases.
Yeah, they're not putting all their eggs in one basket.
So what's their strategy with each type of hardware?
Well, they're leveraging GPUs for their ease of use and wide availability. They're actually building a whole GPU network.
A whole GPU network.
Yeah, and they're developing an optimized CUDA SDK specifically for ZK.
So it's like they're building this ZK powerhouse in the cloud.
Exactly.
And anyone who needs a speed boost can just tap into it.
Yeah, like a ZK utility company.
Yeah, like a ZK utility company. I like that.
But they're not stopping there.
Okay.
They're also harnessing the power of FPGAs
Okay.
to get even more speed and efficiency.
Right.
They've actually achieved record speeds for key ZK computations.
Okay. Like what?
Like those MSM and NTT things we talk about.
Wow.
Even surpassing some of the latest GPUs.
Hold up, FPGAs are beating GPUs.
They are.
I thought GPUs were like the performance champs.
Right, but it comes down to that customization we talked about.
Okay.
By fine-tuning the FPGA's architecture to the very specific needs of ZK algorithm,
Right.
cysic is eliminating all that unnecessary overhead and just streamlining the whole process.
So they're getting rid of the fluff.
Exactly.
Just like straight to the point.
Yep, and on top of the speed gains, FPGAs are incredibly energy efficient.
No.
Which is a big plus compared to those power-hungry GPUs.
All right, so FPGAs are the dark horse in this race.
They are.
More efficient, potentially even faster than GPUs.
Yeah.
What about ASICs? Are they going all in on that too?
They're being a bit more cautious with ASICs.
Okay.
Which makes sense.
Yeah.
The ZK landscape is evolving so rapidly that a custom-designed ASIC could become obsolete pretty quickly.
Right, yeah.
So while they're exploring ASIC development for the long term, their current focus is really squeezing every ounce of performance out of GPUs and FPGAs.
That's a smart move.
Yeah.
Don't get me wrong, all this hardware talk is fascinating.
Yeah.
But what does it actually mean for the future of ZK? Like, what's cysic's big picture vision here?
Well, they have this really ambitious plan called cysic network.
Cysic network, okay.
And it's all about creating a decentralized network that's dedicated to ZK-proof generation and verification.
Wait, a decentralized ZK network?
Yeah.
That sounds huge.
It is.
How would that even work?
So imagine a network where anyone can contribute their hardware.
Okay.
Whether it's a powerful GPU,
Yeah.
a custom-built FPGA,
Right.
or even just a regular computer or smartphone.
Yeah.
cysic network aims to connect ZK projects that need acceleration with people and institutions who can provide that hardware power.
So it's like a global marketplace for ZK acceleration.
Exactly.
Powered by the community.
Powered by the community.
That's pretty revolutionary.
Yeah.
But if everyone's generating proofs, who's making sure that they're actually correct?
That's where community validators come in.
Okay.
Anyone, even with just a regular computer, can join the network as a validator.
Okay.
And help to verify the correctness of ZK proofs.
Gotcha.
It's a way to contribute to the network's security and earn rewards at the same time.
Okay, so we've got proof generators,
Right.
hardware providers, and validators,
Yeah.
all working together.
Working together.
This cysic network is shaping up to be a pretty big deal. But how can everyday people like me get involved?
Yeah, great question.
Is this just for big institutions with tons of computing power?
Not at all.
Okay.
cysic is actually developing specialized hardware devices designed specifically for cysic network.
Ooh, new gadgets.
New gadgets.
Tell me more.
They're called ZK Air and ZK Pro.
ZK Air and ZK Pro. Okay,
Yeah.
what are those all about?
So think of ZK Air as like a portable device, something like a power bank for ZK acceleration.
Okay.
You could plug it into your laptop or even your phone to give your ZK applications a speed boost.
Interesting.
It's designed to be super user-friendly.
Okay, so ZK Air is like the entry-level option.
Exactly.
Perfect for everyday ZK needs.
Yep.
What about ZK Pro? Is that more for the hardcore users?
Exactly. ZK Pro is more like a powerful mining rig
Okay.
designed for large-scale ZK-proof generation.
Gotcha.
It'll have serious processing power,
Mm.
enough to handle even the most demanding ZK applications,
Like what?
like ZK rollup, ZKML, all that cutting-edge stuff.
Wow, so it sounds like cysic is building a whole ecosystem here.
They are.
From individual users with ZK Air to institutions running ZK Pro,
Yep.
all connected through this cysic network.
Exactly.
It's like they're creating the infrastructure for a whole new ZK-powered world.
Yeah, it's really exciting.
But it also sounds incredibly ambitious.
It is.
Are they really going to pull this off? I'm still processing all this cysic stuff.
Yeah,
It's a pretty wild vision, right?
it is.
It's like building specialized hardware, creating a decentralized network, bringing ZK acceleration to everyone. It's like
Yeah.
they're trying to like single-handedly launch ZK into the mainstream.
It's a big goal.
I gotta admit, though, I'm a little skeptical.
Okay.
It all sounds a bit too good to be true.
I get it. It's definitely a bold plan. There's no doubt about that.
Yeah.
But here's the thing.
Okay.
cysic isn't just like some random startup with a crazy idea.
Right.
Their vision actually aligns really well with what Vitalik Buterin has been talking about.
Right.
Remember, he's been saying that hardware acceleration is the key.
Yeah, he's like the ZK oracle at this point.
He is.
If he's excited about it, there's probably something there.
Totally.
But even if cysic pulls all this off,
Yeah.
what does it actually mean for the average person?
Right.
We've been talking about blockchain this, CK, rollups that.
Yeah.
But how will ZK hardware acceleration actually touch people's lives outside the crypto bubble?
That's where things get really interesting.
Okay.
Because ZK tech has implications far beyond just cryptocurrency.
Okay.
Imagine a world where you could prove your identity online
Okay.
for things like banking, voting, accessing services
Right.
without revealing any personal information. No more sharing your social security number or scanning your driver's license.
Interesting.
You could just use a ZK proof
Okay.
that says, hey, I am who I say I am, without giving away all your sensitive data.
Okay, that's pretty mind-blowing.
Right.
It's like having ultimate control over your digital identity. You decide what to share, what to keep private.
You're in control.
What else could we use this ZK magic for?
Well, think about secure and private voting systems,
Okay.
where every vote is counted accurately, but nobody can tell who voted for what. Or imagine a healthcare system where you can instantly share your medical records with a new doctor without compromising your privacy.
Wow.
ZK proofs could even revolutionize supply chains,
Okay.
making sure that products are authentic and ethically sourced without revealing any confidential business information.
The possibilities are kind of endless.
They really are.
It's like ZK unlocks this whole new level of trust and transparency in the digital world.
Yeah, it's pretty amazing.
It sounds almost utopian, to be honest.
It does.
But is there a dark side to this?
That's a really important question.
Yeah,
And it's something that we need to be really mindful of.
for sure.
Like any powerful technology, ZK has the potential for misuse.
Okay.
For example, some people worry that it could be used to hide illicit activities.
Mm-hmm.
But it's important to remember that these concerns aren't unique to ZK.
Right.
They're challenges that we face with any kind of privacy-enhancing technology.
So it's kind of a double-edged sword.
Yeah.
Like most tech advancements.
For sure.
It all comes down to responsible development and making sure this stuff is used for good.
Absolutely. It's a shared responsibility among developers, policymakers, and just the community as a whole.
Yeah, we've got to work together on this.
Exactly.
All right, well, we've covered a lot of ground today.
We have.
From the nitty-gritty of how ZK proofs work to the potential impacts of Cysic's grain vision.
It's been a journey.
Yeah, it's been a wild ride.
It has.
But before we wrap up, I want to leave our listeners with something to ponder.
Okay.
We've seen how ZK could change everything from online identity to global trade.
Right.
But what if we think even bigger?
Okay.
What happens when this hardware acceleration stuff really takes off?
Yeah.
Like folks like Buterin are predicting, could we see a whole new wave of decentralized applications? Things we haven't even imagined yet.
It's possible.
That were impossible before because of those computational limits we talked about.
That's a fantastic question. And honestly, I don't have the answer.
Right.
But that's the beauty of this whole space.
Yeah.
It's constantly evolving, pushing boundaries, and defying expectations.
I love that.
Yeah. And I think the best we can do is stay curious, keep exploring, and see where this ZK journey takes us.
Couldn't have said it better myself.
It's an exciting time.
It is a huge thanks to our expert for navigating this wild ZK landscape with us.
My pleasure.
And to all our listeners out there, keep those brains buzzing and stay tuned for our next deep dive.
See you next time.
We'll catch you on the next one.